and we're about to begin our talk on the next-gen order fulfillment powered by flexible robotics. And you guys might wonder, what is that? What is this guy going to talk about? Before that, I want to begin by explaining the problem we're trying to solve here. By first talking about what order fulfillment is and why this is a multi-billion-dollar industry. That still, even today, companies have not figured out what the best solution is. And every year, we get new and new solutions to figure out how to solve order fulfillment. At the very basic of it, order fulfillment is about creating orders for a customer. So usually a warehouse that has an order fulfillment operation has 3 different stages to it. The inbound stage, where you gather all of your single SKU pallets together and coming from manufacturers. Then you have a picking stage, where you're mixing all these single SKU pallets together in an order and then going outbound, delivering the final set of packs, we call it mixed SKU packs, to be shipped outside of the warehouse. But just trying to break down these 3 processes a little bit more, let's talk about inbound flow. And just dive in 1 layer deeper, try and figure out what that is. So in the inbound flow, you first get your pallets coming in from the truck. And most likely, they're going to get placed into dense storage. And a warehouse can have tens of thousands, even hundreds of thousands of these types of locations, depending on how big your operation is. However, because the storage is dense, the retrieval from that storage is not that fast. So in order to speed up the order fulfillment process, there's a buffer that orders that are about to be fulfilled, they go to this buffer stage where it's like really fast, pallets are getting in there. And then finally they get sent to picking. When the inbound pallets, they become empty, then there's like an empty return flow. For picking, it's basically you get your pallets from the buffer and you're building a partial pack. And then there's this magic in the middle that we call that, it's either automated, it's human picking, manual picking, robot picking, whatever it is. Something that will take the parts out of your pallets and make a partial pack into that. And then your outbound flow, where from your picking stations, you are getting partial pallets. From there, you have to merge them somehow, then wrap, label, and release them to shipping. So this is another simplified view of the whole process we call order fulfillment. But as you can see already, there's like 10, 15, 20 different sub-processes, subsystems that have to actually work in cohesion together to make this a reality. And this is what makes it challenging. Currently, we have a lot of manual labor doing this. People are manually handling pallets, they're manually taking cases off the pallet, and they're manually wrapping the pallets, because that is flexible. You can basically swap these resources anywhere your operation needs. However, there are training and operational costs. And usually a warehouse would look something like this, where you have your inbound flow, you have a dock area, you put all those pallets into a rack, and then after you take them out of a rack, you sort them, and you try to build your mixed SKU pallets so you can ship them out. And most warehouses today look like this. However, there is also the automated way of doing some of these tasks. And a lot of warehouses nowadays, I wouldn't say the bulk, but a good number of them, have this automatic storage and retrieval system. And as you can see, there's a lot of metal here. There's a lot of infrastructure that has to be built in order to put something like this in operation. And your capital expenses are through the roof. It takes somewhere from 30, 40, 50, maybe even $100 million to put a system like this in place so that you can automate just a part of that big flow that I just mentioned. So the reality today is customers really have to choose whether they want manual flow or the ASRS flow, right? And one is super expensive in capital expenses, the other one is super expensive in operating expenses. And really, it's not getting us to full automation with the current choices we have. So let me talk a little bit about some of the challenges of why it is hard to fully automate this. And the biggest one right now is meeting the ROI. For those of you that are integrators out there and are delivering solutions, you probably have this conversation 24/7 with your customers. You know, is the return on investment going to be great for me? And what is it? Is it 2 years, 3 years, 10 years, 9 months? And this is the way I see right now systems in the market. One of the fallbacks that they have, which is there's a lot of stuff that goes into an automation system, a lot of equipment, a lot of conveyors, a lot of racks, a lot of metal. And there's not that much intelligence to them. It's basically like dumb motors, dumb whatever, just rolling your cases around the warehouse trying to deliver it. And so, unfortunately, those types of systems, the ROI is pretty low. And one way to increase that, and the solution that I've seen be very effective, is you do the opposite. You have high intelligence with minimal equipment. So instead of having a very complicated conveyor that singulates your cases, does a reorientation, does checking, make sure it's the right SKU is on there, you instead have more sensors in the system, more processing to figure out what is on there and what the optimal control is. And if you can solve the optimal control problem, you actually need less equipment, or that equipment will be much, much less expensive. And unfortunately, or fortunately, whichever way you want to look at it, we live in a world where computation is getting exponentially cheaper. So I say it would be rather dumb not to focus more on how do we increase intelligence of these systems, rather than how to make more complex hardware systems. And that will give you the high ROI. Another challenge is data integrity. So this is what I see in the market today. There are all these subsystems out there. Each of them are independent, which is not a bad thing. It's a good thing. They each have their own intelligence and computation involved, and they each have their own databases. However, because they're dealing with inventory, they're dealing with real stuff that has to go through the warehouse, each of these databases now have to talk to each other. They have to interoperate with each other. They have to have common interfaces, right? And you might think, oh, the inbound doesn't need to talk to outbound. Actually, it does, because in the end, you need the full consistency thing. So what happens is people create very complicated super systems or warehouse management systems to try to standardize all this. And that in itself is like a lot of money, like many, many millions of dollars just to figure out the software for all this. And the way I see the solution, and many companies are trying to do this today, although I don't think any one of them has been successful, is you have a common database that every single system shares. And actually, dare I say, that if you do a really good job at automation, a really good job at tracking things into your system, we can even call this a real-time digital twin. Just imagine, in real time, you have a snapshot of what's going on in your warehouse. And every single item is tracked in this real-time digital twin. And every time a system, like an inbound system, wants to put something in the real world or wants to take something out of the real world, it has to interact with a digital twin to get it. And so if we solve this real-time digital twin problem, we actually unlock the key and one of the challenges to automating order fulfillment. And if anybody of you have delivered systems like that, you would know that every single customer has a wish list. They want the system to be scalable, which means, they ordered a system to have a 20,000 case throughput, and in the middle of the order, they say, oh, by the way, we want 40,000. Shouldn't that be just double the price? Or they want it flexible. Today they tell you they just want cases of a particular size to be handled. Tomorrow they're going to say, well, we actually wanted the small cases too. We want to expand our business. Or they want it to be reusable. Today they have a warehouse that's maybe 100,000 square feet and they want to upgrade to a warehouse that's 1,000,000 square feet. And they want all the systems that they bought before to be reused in the new warehouse. Well, how do we really get that in automation systems? Is there really a solution? And I think through my experiences with doing a lot of these types of industrial automation systems, I think we have finally gotten close to a really good, solid answer on what that is. And I want to tell you all about it. But first, let me tell you about who Mujin is and what we do. So we were founded in 2011, and the core of our business is to create an industrial intelligent robotics platform. One platform to do all of your industrial automation needs. And we started first with just basic picking because, in my mind, that was the hardest thing. That was the one thing we couldn't automate yet. Let's start at the hardest core problem first and work ourselves up through the chain. So we did that for the first 5, 6, 7, 8 years. And after we solved that problem, we now asked ourselves the question, well, can we apply these technologies to all of the other conveyor systems, to all of the other automation systems, and to create one coherent environment controlled by one platform? And we actually, for the past 13, 14 years, this is exactly what we've been doing. And now our controller is capable of connecting to any device and controlling any device in a standardized and coherent manner. And then you build intelligence. You get all of the standardized intelligence components on top of that for free. And part of the secret sauce to the Mujin controller and the core technology that makes everything happen is this idea of machine intelligence. So this is in contrast to artificial intelligence, or as many people today think about it as machine learning. Because machine learning is about learning from the behaviors of, let's say, a human being and trying to have a machine copy that. But I ask, why do you want to copy something that's imperfect? It should be perfect. For example, a train that goes from A to B, everything is known about it. Its failure points, how fast it's going to go, how to maintain it, how much weight it can surpass, what type of environment conditions it can work in. And then people can rely that it's going to get you to your destination. In the same way, you should think about a robot system. It should be perfect in every single sense, and you should be able to predict exactly what's going to come out of it. And so we've actually discovered 4 different components of machine intelligence that are written here. It all starts with the digital twin, which is you're trying to mimic and synchronize the real world with what's going on in your digital world. From there, you're doing real-time control. You have your integrated vision that's sensing what's happening in the real environment. You're then feeding that into a planning module, which tries to reason and deliberate about what types of actions your systems can take so that they are safe. And that feeds back into the digital twin. So in the end, you get this feedback loop, which is literally the definition of robotics at many, many different levels of control. We've actually gotten so good at creating these digital twins that we can literally put multiple different robot cells, multiple different subsystems into the same atomically managed digital environment and just have them work seamlessly. And you can actually see whenever a robot is placing cases or picking up cases, or whenever cases are going in and out of the conveyor, everything gets managed by this digital twin. Whenever you have a sensor input, it should be updating your digital twin. And whenever you want to reason about an action, you should be using your digital twin for that. Oh, there we go. Perfect. So let me talk a little bit about some of the processes involved in order fulfillment. In the very beginning, we have truck unloading, when you're first getting to the warehouse. Yes, sometimes we have pallets that come in out of the truck directly, but a lot of times we have floor-loaded cases. And there is a huge operation right now of trying to get them out of the truck very, very efficiently. And every single berth dock has this problem. But up to now, there hasn't been the correct solution, the correct hardware, the correct software to make this happen. And actually, combined with all of our efforts to do picking for 6-axis arms at Mujin, recently we've unveiled a robot which can solve the truck unloading problem. And this is a unique design, as you can see, because it's not just grabbing items and putting them on the conveyor, it is the conveyor. It is literally eating items, eating cases, and spitting them out. One of the interesting things about this is because you're supporting with the conveyor the case, you can actually pick up very, very heavy cases that normally a lot of the other robots or solutions that you see here that are doing like side picking, they'll never work. But once you unload them from the truck, and you get them onto a conveyor, you're going to have to make single scoop pallets out of that. And that is yet another process, whether it's through manual labor or through automated picking, that has to be done. This is an example of what you can do with, if you can imagine this conveyor, the truck unloader is feeding into this robot system. And this particular robot is figuring out, okay, it's this case, it's these particular dimensions. Okay, I'm going to call this mobile robot next to me so I can go and pack it. And that's one way to automate the single SKU palletizing process. Once it's on this mobile robot platform, this pallet, it has to get shifted around, shuffled around into your warehouse. Whether that is going into storage or whether that is going into your buffer, that is up to the user to decide. But these types of mobile robots are actually very, very flexible and very scalable, right? As you can see, there is literally no infrastructure necessary to have it move. At the most, you're pasting, as you can see on the floor, you're pasting some QR codes. But that's it. In like an hour or two, you can be done with that operation. And immediately you can go and shift around your layout however you want it to. Once we have all of the single SKU pallets created, now it's time to create our orders. And instead of having a very complicated sorting operation or mixed SKU sequencing buffer operation, we have the pallets, the single SKU pallets, come to the robot. And the robot is building now the mixed SKU pallets on the fly. And this technology actually enables you to be able to do this mixed SKU order pallet building with minimal infrastructure. It's just the mobile robots and it's just a picking robot. And as you can see in the video, this picking robot is not even bolted to the ground. It's like on a big heavy metal plate. So if you want to shift your operations, just pick up the heavy metal plate and do whatever you want. Furthermore, with recent advances in picking technology, the robots like this can now be multi-picking. So instead of picking one at a time, depending on the situation, the robot would be able to pick up multiple boxes, and go and place that in the pallet. And then you have your mixed SKU pallet ready to be wrapped, labeled, and shipped. But you can even go one step higher, because once it's on a robot like this that it's picking, well, why not just create a big gripper that's the size of your pallet? That way you can pick up a whole row of cases at once, and the same system that can now do your mixed SKU pallets can also build extremely fast single SKU pallets. It's almost like a layer picker and a mixed SKU picker all combined into one system. And advances like this in the intelligence segment and in the hardware segment allow us to get the scalability, flexibility, and reusability that traditional automation systems could never achieve. Robots like this go up to 1,000 and even surpass 1,000 cases an hour. So let me give you a view of this automation system that is a little bit more, in terms of system format. You would usually have a warehouse execution controller at the very center. That would then, you can see the picking cells are connected to that warehouse execution system. Each of them, they have their own controllers, they have their own digital twins. Then you have the mobile robot control system managing the robots to the side, which are then interacting with forklifts, interacting with pallets, and interacting with your other external systems. So actually a system like this with mobile robots and picking robots combined becomes extremely flexible. And you don't need to go and invest $30, $40, $50 million just to try it out. You can just get one picking robot, a couple of mobile robots, and immediately be able to try it out to see if it works for your application. Dare I say, it's almost free compared to traditional automation systems. The warehouse execution system obviously has to be building your mixed SKU orders and batching them and sorting them correctly. But this is all software. There's no really integrated hardware that's part of this. And if you need more computation power, just throw more computation power at it. It's easy. And picking system is the same thing, with the Mujin controller being at the center of the operation. And this is an example layout, if anybody's curious what that would look like. Here the robots are north, and all of your temporary buffer locations are south, and then you have your AGVs going through them. And luckily for you guys, for this show, we're actually exhibiting all of these technologies in our booth today. This is a rendering of what it looks like. You can actually see the real thing over there, if you can see our name. It's like, just stop over there. Let me talk a little bit about it, just to give you a taste of what you can experience. So here is our latest generation of truck unloading. And this particular truck unloader actually is it's more mobile. You can place it on different conveyors if you want to, or flex conveyors. It can literally go into extremely deep 53-foot trailers if you need it to be. And it can take out any box you want. Then we have our single SKU pallet building, which, if you can see from the picture of the right, basically the conveyor from the truck unloader gets scanned by a real-time vision system, figures out what the sizes of these parts are, and sorts it correspondingly so that each of the robots can build your single SKU pallets, which are then managed by a bunch of robots, mobile robots, You can actually see our big mega gripper in action here, doing your mixed cube pallet building. And last but not least, the full digital twin of all of these cells integrated together, moving seamlessly and doing all their communication in this one platform. And in order for the demos to happen over there, there was 6 or 7 Mujin controllers that are all interacting with each other in this standardized way to make it happen. So as a system builder or as an end user, this is very valuable for you guys. Because now, for the first time, you can actually understand what's going on in the world. You can just look at the digital twin. You think a box is lost, look at the digital twin. Is it there or not? It makes it very easy to see where the problem is, what got mistracked. And you can roll it back. You have like a recording, right? A history of what went when. So you can always play back and figure out at exactly one point in time a problem happened, or if you need to do maintenance, or if something's not working the way it should be. Because that's what robotics should be. It should be about creating a perfect system and tracking it perfectly. And that's what we're trying to deliver. So, closing remarks, just a couple of thoughts out there. Why automate? People sometimes ask me, okay, so Mujin, who's your biggest competitor? It's the manual labor. That's our biggest competitor. Do we meet the ROI or not? That is the #1 reason why we cannot get our project. It's not because XYZ company is doing something. There's not enough of those companies, by the way. So here's some closing thoughts, especially for end users out there. By automating, you are enhancing your net productivity. It doesn't mean you have to go and release your staff. It just means that now the current staff that you're employing can be a lot more efficient. You're lowering your operational costs. You don't have any more training costs. You just have one set of systems that will work for you. But most important, everyone nowadays is automating. And if you look at the major companies today in the space, in the logistics space and transportation space, the major companies and the biggest companies, the ones that are thriving the most, are the ones that are automating the most. So if there's anything that you guys should take from today's discussion, is that those who automate first win first. So with that, guys, thank you. It was a pleasure to talk to you and tell you my thoughts about automation. All right, cool. Well, thank you.